You guys aren't in it. All right. Two-dimensional and three-dimensional figures. Here we go. A crop circle or crop formation is a large geometric pattern created by flattening a crop. The artist who creates these formations, called circle makers, plan their designs on paper using a compass and straight edge or by using dynamic geometric software. Measurement is a key component in creating a successful crop formation. Circle makers use string to ensure that circles have a uniform radius when creating other geometric shapes. They use GPS devices and surveying equipment to guarantee that lines are straight and perimeters are uniform. Right, and here we have a little example of a crop circle. All right, so this lesson, like I said, is over two-dimensional and three-dimensional figures. So there is a lot in it. So as you can see in this lesson, you will learn there's 10 different things here because there's 5 for two-dimensionals and 5 for three-dimensional. The vocabulary, there is a lot of vocabulary because we're going to go over all the stuff for two-dimensional and all the stuff for three-dimensional. So there's a ton of vocabulary. So make sure that you go through the vocabulary. It's on here for you. I will explain a little bit of it as we're going through as well. Polygon is a closed plane figure with at least 3 straight sides. The perimeter of a polygon is the sum of the lengths of the sides of the polygon. Some shapes have special formulas for perimeter, but they're all derived from the basic definition of perimeter. The circumference of a circle is the distance around the circle. Area is the number of square units needed to cover a surface. All right, so all 4 of these are, these 3 are polygons. All right, circle doesn't have a straight line, so it's not a polygon. Perimeter, that's the outside. And you would be amazed how many students get this confused. Perimeter is the outside. Area is the inside. All right, and circumference is a fancy way of saying perimeter for circles. You'll want to make sure that you know the different area formulas for the different shapes. It'll come in handy when you are working through this lesson. You can use the distance formula to calculate different characteristics of 2D figures on the coordinate plane, and then use those characteristics to determine the perimeter or circumference and area of the figure. Right, so the distance formula that we learned a few lessons back we'll be using to help us with perimeter and whatnot for these different shapes. Recall that a polygon is a closed figure formed by a finite number of coplanar segments called sides, such that the sides have a common endpoint, are non-collinear, and each side intersects exactly 2 other sides, but only at their endpoints. If any of the lines containing the sides of a polygon contain a point in the exterior of the polygon is a concave polygon. Okay, so up here, concave, a polygon with 1 or more interior angles that measures greater than 180 degrees. Convex, a polygon with all interior angle measures less than 180. These are convex polygons, these 3 right here. We have not seen an example of a concave polygon yet. An equilateral polygon has all sides congruent, right? So a square is an example of an equilateral polygon because all 4 sides of a square are congruent. Equilateral triangles are examples of equilateral polygons because all 3 sides of the triangle will be congruent. An equiangular polygon has all angles congruent. So again, a square is an equiangular polygon. An equiangular triangle or equilateral triangle is an equiangular polygon. And then a regular polygon is a convex polygon that is both equilateral and equiangular. So a square is a regular polygon. An equilateral triangle is a regular polygon. Rectangles are not regular polygons because their sides are not all the same. Any questions on that? Okay. So we're going to go over check perimeter, circumference, and area. So if you would please get on to the McGraw-Hill site and do the if it'll load. Let me try refreshing it. Oh, none of these are loading. Check perimeter, circumference, and area. That's the one I want you guys to do on the McGraw-Hill site. Go ahead and get logged into that and do that for me if you would, please.